Let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool. Hello everyone. I'm PS Chatterjee, and a warm welcome back to my channel. Before we dive in, a quick note for my non-civil engineer viewers: while we'll be tackling some technical concepts today, please feel free to follow along. Simply treat the engineering terms as numbers and focus on applying the Excel process to your own DIY spreadsheet projects. In my last two videos, we thoroughly covered the theoretical aspects and the design of a doubly reinforced beam for bending stress, first through a detailed PowerPoint presentation, and then applying it in Excel. Today's video, titled Shear Stress in Doubly Reinforced Beam, IS-456 Part-03B, is an Excel presentation, and a perfect DIY project, especially for my fellow civil engineers, and this is also continuation of Part 03. If you're new to the channel, I highly recommend checking out Part 1, Part 2, Part 03, and Part 03A, of this series first. And for an even stronger foundation, my IS-456 singly reinforced beam design, bending moment, shear force and deflection limits and checks in Excel, series, parts 1 through 7, will be incredibly helpful. In this episode, we're going to dive into several critical shear stress calculations in Excel. To help us visualize the tasks ahead and recap the necessary steps for shear design, let's now move to our next slide. Alright, we're now on the slide titled where we concluded our Part 03A. This marks the starting point for our discussion on Part 03B. In this episode, we'll be diving into the Excel formulas you'll need for the remaining cells, from tau V all the way to stirrup spacing. You'll also learn about conditional formatting for some of these cells. I genuinely hope you find this episode valuable and enjoyable. Please feel free to leave your feedback and questions in the comments below. If you're interested in understanding the step-by-step calculations behind the software, this video will be incredibly helpful. So, if you find it useful, please consider giving it a big thumbs up. Remember, sharing knowledge means enhancing knowledge, so I encourage you to share this video with others. And if you wish to support my honest efforts, subscribing to the channel is the best way to do so. Let's build this community together for mutual benefit. Thank you in advance for your cooperation and support. Now, let's move over to the next slide. Task number 12. Now, I am going to demonstrate how we can put the formula under the cells with headings tau V and tau C max. Tau V is the calculated shear stress, and tau C max is the maximum design shear stress with the application of calculated shear reinforcement. The unit for both of these is newtons per square millimeter. First, I will start with tau V. You will find three if functions in this formula, along with the application of the and function in proper place. The formula for tau V begins, equals if, open parenthesis, if check underscore 03 equals, within quotation, check, with double exclamation, comma, then a blank quotation. Comma, if, open parenthesis, and, open parenthesis, check underscore 03 equals, in quotation, OK, comma, and VU is less than or equal to 0. Close the parenthesis for and function. Comma, then within quotation, VU, with double question marks, comma, if, open parenthesis, n, open parenthesis, check underscore 03 equals OK, comma, and VU is greater than 0. Close the parenthesis for n function, comma, then VU multiplied by 1000, divided by, open parenthesis, B multiplied by D underscore EFF. Close that parenthesis for denominator, comma, and finally, a blank quotation. Close parenthesis for all three if functions. Simple meaning of this formula is, if the text in the cell, check underscore 03 is, check, it will keep the cell blank. If the text in the cell, check underscore 03 is, OK. And value of shear force in cell under the heading shear within bracket VU is 0, then Excel will intimate us for the value of VU, by the text VU with double note of interrogation. If the text in the cell, check underscore 03 is, OK. And the value of shear force, VU is greater than 0, then Excel will calculate the value of tau V, by following the equation, VU multiplied by 1000, divided by, B, multiplied by, D underscore EFF. Otherwise cell will remain blank. Pasting and testing for the cell value of tau V. Now, by copying this formula, from formula box, I am pasting it under the cell with the heading tau V. We are seeing that the value of tau V is 0.640, because in the cell, we have check underscore 03 equal to OK, and the value of the shear force VU is 50 kN. Next, I am changing the value of VU from 50 to 0 kN. Now, we are seeing a text, VU, with double question marks, in this cell. This serves as a reminder to provide a positive value in the cell stipulated for shear force, or VU. To get the text check in the cell check underscore 03, I am changing the value of MU from 150 to 250 kN. As a result of this change, we are seeing that the cell with the heading tau V, along with the cells with headings beta and tau C, have turned into a blank cell. So, we can confirm that our formula for tau V is working correctly. By the help of undo option I am returning to the starting point. Task number 13, conditional formatting for tau V. Equals n, check underscore 03 equals o.ktvtc underscore max. We know that, under no circumstances, the value of tau V can be more than tau C max. To indicate this, we need to apply conditional formatting to the cell named tau V. The formula for this conditional formatting is equals, open parenthesis, n, open parenthesis, check underscore 03 equals, in quotation, OK, comma, tau V greater than tau C max, close parenthesis for the n function, close parenthesis for the overall formula. Once again, this is a true or false function. Simple meaning of this formula is, if check underscore 03 equals to, OK, and tau V, greater than tau C max, the condition will be true. Now, for conditional formatting for the cell, first select the formula from formula box and select the copy option. Now go to the Home tab on the ribbon, then select Conditional Formatting option, then click on New Rule, then select Use a Formula to determine which cell to format option. Then on the dialog box, paste the formula that we copied earlier. Now click on Format option, the From Fill option select Yellow Fill. To accept the condition, click on OK. Our conditional formatting is ready. Task number 14, Formula for the cell with heading tau C max. The formula for tau C max is, equals if, open parenthesis, check underscore 03 equals, within quotation, check, comma, then a blank quotation. Comma, if, open parenthesis, if FCK equals 15, comma, then 2.5. Comma, if, open parenthesis, if FCK equals 20, comma, then 2.8. Comma, if, open parenthesis, if FCK equals 25, comma, then 3.1. Comma, if, open parenthesis, if FCK equals 30, comma, then 3.5. Comma, if, open parenthesis, if FCK equals 35, comma, then 3.7. Comma, if, open parenthesis, if FCK is greater than or equal to 40, comma, then 4. Comma, and finally, close parenthesis 6 times for all 6 if functions. The simple meaning of this formula is, if the text in the cell check underscore 03 is check, the tau C max cell will remain blank. However, when check underscore 03 is O.K, Excel will return the value of tau C max as follows. For FCK 15, the value is 2.5. For FCK 20, it is 2.8. For FCK 25, it is 3.1. For FCK 30, it is 3.5. For FCK 35, it is 3.7. And for FCK 40 and above, the value of tau C max will be 4. The unit for all these values will be newtons per square millimeter. Now, by copying this formula from the formula bar, I am pasting it under the cell with the heading tau C max. We are seeing that the value of tau C max is 2.80 newtons per square millimeter, since we are currently using M20 grade concrete. Testing for tau C max. Since we know the value of tau C max solely depends on the concrete grade, I am changing the value of the concrete grade. First, from M20 to M25. And observe, the value of tau C max changes from 2.80 to 3.1 newtons per square millimeter. Now, I am changing M25 to M30. And the value of tau C max changes from 3.1 to 3.5 newtons per square millimeter. In this way, tau C max will adjust itself with the change of the concrete grade. Testing the conditional formatting for tau V. Presently, the value of Vu is 50 kilonewtons. Now, I am changing the value of Vu from 50 to 250 kilonewtons. Look closely. The cell named tau V has turned into a yellow cell, indicating that we have crossed the permissible boundary. Now, by using the undo option, I am returning to our starting point. Task number 15, Formula for the cell with heading VUS. Now, I am going for the formula under the cell with the heading, VUS. A situation we may face is when the calculated tau V is greater than tau C but less than or equal to tau C max. In this situation, the difference between the calculated shear force, Vu, and the designed shear force, that is, the product of tau C, B, and D underscore EFF, divided by 1000, here, 1000 will change the unit from newtons to kilonewtons, this difference is known as VUS. And SV is the calculated spacing for the shear reinforcement. First, I will start with VUS. The formula for VUS is equals to if, open parenthesis, check underscore 03 equals to, within quotation, check, comma, then a blank quotation, comma, if, open parenthesis, n, open parenthesis, check underscore 03 equals to, in quotation, OK, comma, VU less than or equal to 0. Close that parenthesis for the n function, comma, then within quotation, VU, with double question marks, comma, if, open parenthesis, n, open parenthesis, check underscore 03 equals to, in quotation, OK, comma, or, open parenthesis, ASV, less than, or equals to, 0, comma, ASV equals to blank quotation, close parenthesis for the OR function, close parenthesis for the n function, comma, then within quotation, ASV, with double question marks, comma, if, open parenthesis, n, open parenthesis, check underscore 03 equals, within quotation, OK, comma, VU, greater than 0, comma, ASV, greater than 0, comma, TC greater than, TV. Close parenthesis for the n function, comma, then within quotation, nominal, comma, if, open parenthesis, n, open parenthesis, check underscore 03 equals to, within quotation, OK, comma, VU, greater than 0, comma, ASV, greater than 0, comma, TC max greater than, TV, comma, TV, greater than, TC, close parenthesis for the n function, comma, then, VU minus TC multiplied by B, multiplied by D underscore EFF, divided by 1000, comma, within quotation, n slash a, finally, close parenthesis 5 times for all 5 if functions. The simple meaning of this formula is, if the text in the cell check underscore 03 is check, it will keep the cell blank. If check underscore 03 is OK, and the value of VU is less than or equal to 0, it will print the text VU, with double question marks in this cell. Why? We already know that. If, check underscore 03 is OK, VU, greater than 0, ASV less than equals to 0, or a blank cell, then Excel will type, ASV, as a reminder for providing shear reinforcement. If the text in the cell check underscore 03 is OK, and the value VU is greater than 0, also, the value of ASV is greater than 0, and TC, greater than, TV, it will print the text nominal in this cell. If check underscore 03 is OK, and the value of VU is greater than 0, also, the value of ASV is greater than 0, and TC max greater than, TV, and, TV, greater than, TC, it will calculate the value of VUS, in kilonewton in this cell, by following the formula, VU minus, TC, multiplied by, B, multiplied by, D underscore EFF, divided by, 1000. Otherwise, it will type n/a, stands for, not applicable. Presently, we are observing the text nominal. Because the value of Vu is 50 kN, value of ASV is 201.06 square millimeter, value of TC is 0.821 Newton per square millimeter, and value of TV is 0.640 Newton per square millimeter, which is less than the value of TC. Let's move for the spacing of the stirrups or SV. Task number 16, formula for the cell with heading SV. SV, or the spacing for the shear reinforcement, is our ultimate destination for the shear design of a beam. I have already told you that this spacing we will calculate on the table named Table for Stirrups on sheet table _F, and that value we will bring to the cell with the heading SV with the help of the VLOOKUP function. Now, the formula for SV is: if, open parenthesis, check _03 equals to, within quotation, check, comma, blank quotation. If, open parenthesis, n, open parenthesis, check _03 equals to, within quotation, OK, comma, Vu less than or equal to 0. Close parenthesis for the n function. Comma, then within quotation, Vu, with double question marks. Comma. If, open parenthesis, n, open parenthesis, check _03 equals to, within quotation, OK, comma, Vu greater than 0. Comma, or, open parenthesis, ASV less than or equal to 0. Comma, ASV less than or equal to blank quotation. Close parenthesis for the n function. Comma, then within quotation, ASV, with double question marks. Comma. If, open parenthesis, n, open parenthesis, check _03 equals to, within quotation, OK, comma, TV greater than TC max. Close, parenthesis for the n function. Comma, then within quotation, n/a. Comma. If, open parenthesis, n, open parenthesis, check _03 equals to, within quotation, OK, comma, TC max, greater than TV, close, parenthesis for the n function. Comma. VLOOKUP, open parenthesis, case _type, comma, table _F, $A$3 $C$6, comma, 3, comma, 0. Close, parenthesis for the VLOOKUP function. Comma, then a blank quotation. Finally, close parenthesis 4 times for the if functions. The simple meaning of this formula is: if check _03 equals OK and Vu is less than or equal to 0, Excel will type Vu, with double question marks, as a reminder for providing the value of shear force. If check _03 equals OK and ASV is less than or equal to 0 or ASV is blank, Excel will type ASV, with double question marks, as a reminder for providing the value for shear reinforcement. If check _03 equals OK and tau V is greater than tau C max, Excel will type n/a. N/a stands for not applicable. If check _03 equals OK and Vu is greater than 0 and ASV is greater than 0 and tau V is less than or equal to tau C max, Excel will find the value of SV with the help of the VLOOKUP function. For the VLOOKUP function, case underscore type is the lookup value, table underscore F, $A $3 $C $6, is the table array, 3 is the column index, and 0 is for an exact match. Finally, if it finds no match condition, it will leave the cell as a blank cell. In the next portion of the video, we are going to see the conditional formatting for VUS and for spacing SV. Now on the dashboard, we are seeing the value of spacing of the stirrups, SV, at the rate of 250 mm. Task number 17, Conditional Formatting for VUS. This is a special type of conditional formatting. After trying with different permutations and combinations, I failed to create a formula for conditional formatting for the cell VUS. In this cell, I have used the following text, check, with double exclamation, VU, with double note of interrogation, and n/a, as a warning or reminder. Along with this, I have used the text nominal, which does not belong to the warning or reminder category. By using the isText function, I couldn't isolate the text nominal. Along with this, I also had to isolate calculated values from this cell. In this situation, Gemini AI became the savior to me. Gemini AI provided me with the formula to overcome the situation. By editing that formula, I am going to use that. Thank you, Gemini AI. Now, the formula for the conditional formatting of VUS is equals to n open parenthesis not open parenthesis is number open parenthesis search open parenthesis nominal in quotation comma VUS close parenthesis for search function close parenthesis for isNumber function close parenthesis for not function comma not open parenthesis or open parenthesis isNumber open parenthesis VUS close parenthesis for isNumber function comma n open parenthesis isNumber open parenthesis value open parenthesis left open parenthesis VUS comma 1 close parenthesis for left function close parenthesis for value function close parenthesis for isNumber function comma not open parenthesis IS error open parenthesis value open parenthesis VUS close parenthesis for value function close parenthesis for IS error function close parenthesis for not function close parenthesis for the inner and function close parenthesis for the OR function close parenthesis for the outer not function close parenthesis for the final and function. Simple meaning of the formula. Let's explain the simple meaning of this formula. This complex formula checks for two main things in your VUS cell. First, does the cell VUS not contain the word nominal? And second, does the cell VUS not contain any number? This includes numbers entered directly, or numbers that are stored as text, or even text that starts with a number. If both of these conditions are true, meaning nominal is absent, and no number is present, then your chosen conditional formatting will apply, highlighting the cell. Application of the formula. Now, for the application of the formula, first, select the formula from the formula bar and select the copy option. Then, select the cell named as VUS. Now, go to the Home tab on the ribbon. Then select Conditional Formatting option. Then click on New Rule. Then select Use a formula to determine which cells to format option. Then, on the dialog box, paste the formula that we copied earlier. Now, click on the Format option. From the Fill option, select Yellow Fill. To accept the condition, click on OK. Our conditional formatting is ready. Task number 18, Conditional Formatting for Spacing of Stirrups or SV. Equals to is text. Open parenthesis. SV. Close parenthesis. During the calculation of the spacing for the stirrups, we may find some text as a warning. These texts are as follows: check, with double exclamation, or a blank cell. VU, with double note of interrogation, and /a, and ASV, with double note of interrogation. If Excel finds any text in this cell, it will be considered as true, and the formatting will apply. Application of the formula. Now, for the application of the formula, first, select the formula from the formula bar and select the copy option. Then, select the cell named as SV. Now, go to the Home tab on the ribbon. Then select Conditional Formatting option. Then click on New Rule. Then select Use a formula to determine which cells to format option. Then, on the dialog box, paste the formula that we copied earlier. Now, click on the Format option. From the Fill option, select Yellow Fill. To accept the condition, click on OK. Our conditional formatting is ready. We have completed our task for designing the bending stress and shear stress for the singly and doubly reinforced beam in a single Excel sheet, with dynamic interchangeability between a singly reinforced beam and a doubly reinforced beam. In the next portion of the video, we are going to see the testing of the sheet. Stay tuned. Final testing of shear reinforcement design for doubly reinforced beams. We're currently testing check_03. Right now, our ultimate bending moment, or MU, is at 150 kN, and check_03 shows OK. Now, let's change MU from 150 to 200 kN. You'll see that check_03 immediately changes from OK to check, with double exclamations. Because of this, all the cells for our shear reinforcement design, that's tau C, tau V, tau C max, VUS, and spacing, SV, are now blank. This happens because, for the shear reinforcement calculations to even begin for either singly or doubly reinforced beams, the check_03 cell must display OK. Since it's currently check, the calculations can't proceed. So, let's use the undo option to return to our starting point. Testing for VUS. Next, I am changing the value of VU from 50 to 150 kilonewtons. Now, we are seeing the value of VUS equals 85.83 kilonewtons in this cell. Previously, it was nominal. Now, By using the undo option, I am returning to our starting point. Testing the 4SV and other cell value. Presently, the value of Vu is 50 kilonewtons, and our ductility setting equals no. As a result of this, we are observing SV equals 250 mm, as a nominal stirrup spacing. Test number 1, now I am changing the value of Vu from 50 to 0 kilonewtons. Look in the cells tau V, VUS, and SV. We are finding the text VU, with double question marks, as a reminder for providing the value for VU. Now, by the help of the undo option, I am returning to the previous position. Test number 2, now I am changing the value of ASV from 201.06 to 0 square millimeters. Look in the cell SV. We are finding the text ASV, with double question marks, as a reminder for providing the value for ASV. Now, by the help of the undo option, I am returning to the previous position. Test number 3, now I am changing the value of VU from 50 to 250 kilonewtons. Look in the cell SV. We are finding the text N/A. This is because the calculated value of tau V is greater than tau C max. This condition is not applicable. Test number 4, now I am changing the value of Vu from 250 to 225 kilonewtons. We are observing the same result. Test number 5, now I am changing the value of Vu from 225 to 215 kilonewtons. We are observing that the value of SV equals 150 millimeters. Test number 6, now, once again, for the value of Vu equals 215, I am reducing one link. We are observing the value of SV equals 113 millimeters. Test number 7, now, once again, for the value of Vu equals 215, I am going to consider no link. We are observing the value of SV equals 75 millimeters. Finally, I am accepting the ductility detailing, and the value of SV equals 75 millimeters. Based on all calculated values, Excel determines this to be the appropriate minimum spacing for SV. This demonstrates the robust and adaptive nature of our shear design calculations in the spreadsheet. I'm truly energized and have so much more I'd love to dive into. However, I'm conscious of our time together and want to ensure each session delivers maximum value. So, for now, I'll hit pause. And that wraps up shear stress in doubly reinforced beam. IS-456 Part-03. We've covered the doubly reinforced beam and shear stress in detail on our dynamically interchangeable Excel sheet today. I'm taking a brief break to prepare for Part 04, where we'll tackle deflection check limits and the final beam checks for both singly and doubly reinforced beams. Now, for a quick announcement about something many of you have been asking for, the free Excel sheet that I've already demonstrated. I've received so many wonderful emails requesting it, and I'm truly happy to share it with you. To get your hands on it, please carefully read the instructions in the description below this video. It's a two-step process. You'll need to send an email with your request and leave a comment on this specific video letting me know you've sent it. Both steps are absolutely essential. For this beam design series, I genuinely encourage you to build your own Excel sheet first. That's my main goal with these videos. Pre-made sheets often limit you, developing your own truly empowers you. If you hit any snags while creating your sheet,
I'm here to help you, completely free. My aim is to empower your learning and skill development. If you'd like to support my work, there are two ways. Watch my videos in full. Make a contribution, whatever fits your budget, without pressure. You'll find support details in the description. The communication process for this is the same as for Excel sheet requests. Your engagement helps me refine how I share knowledge with you. I hope you enjoyed this episode. Your feedback and questions are always welcome in the comments. If this video helped you, please give it a big thumbs up, share it, and subscribe for more valuable content. Thanks for your cooperation and support.